What I want to discuss today is the issues around system analysis and product design. Clearly, the concern is that a product does not sit in isolation. There are a number of other issues that interface with that product that you need to understand and that the manufacturers need to understand. And in terms of industrial ecology, we need to essentially think about all that the interrelations that exist with a product and with other products and with society. And to that end, that hopefully will allow us to influence the design of products. I mean, the classic, complaint from people who are concerned about the environment, concerned about environmental issues, is that their lifestyle, the products they use, don't necessarily comport and align with their values and beliefs. And it's incumbent upon companies to think about how the design of their products influences society, to allow people, again, to not just feel comfortable with using products that were designed with industrial ecology principles in mind, but of course, from there, how do those products fit back into the circular economy so they can be recovered, either reused as is, or materials recovered and then reincorporated into the product to eliminate the need for extraction from the earth. So the reason I really start with this is that this becomes key and critical, because if you get this wrong, everything else you do, it will be tinkering around the edges. But if you can get this right, this essentially has a significant impact on society more broadly. So why it's important, of course, is that it does show the need to think more broadly about what you're doing. I suspect currently the classic example is going to be the electric car. Um, you know, it is seen as a positive step forward as a unit, as a product itself. Obviously, it doesn't have much emissions. It runs off electricity. But what you have to think about probably are several different layers of impacts on society. The first is, how was that electricity generated? Generated by coal, natural gas, fossil fuels of some sort, that has an implication. And then, of course, the transmission of that power from the generating station to your home has a huge amount of loss. So there's inefficiencies built in right there. And more broadly, so that's one level in terms of the interface between the product, the car, and the power that it uses. But the other, of course, is what is the implications in terms of how we live as a society? What's the balance between private transport and public transport? More private transport, of course, tends to aggravate the issues around sprawl. That then, of course, has repercussions in terms of agricultural land, forest land, wildlands, biodiversity. All of these things are part and parcel of what happens with a single product. And so that's why it's very important for companies to recognize the implications of what they're doing in ways perhaps they've never really done before. Now, systems are obviously complex, and patterns that you examine aren't always obvious from looking at just the components. You literally need to look at all of those different components in their totality. So the brain is more than just a collection of neurons and neurotransmitters. Obviously, there's something else that goes on within the brain that essentially causes us to be, if you will, alive to this earth. A living cell is more than just a nucleus, ribosomes, cell walls, etc. There's something more fundamental about that collection. The economy is more than the sum of individual businesses and workers. It is that collection and the interplay between them. So as a result, the properties of a complex system are classically more than just the simple sum of their parts. Now, for sustainability and sustainable development, there probably are four complex interacting systems. One, of course, is the global economy. It spans the entire world, but obviously that is made up of individuals making their contributions to their needs in terms of economic return, but also their impact in terms of outputs that are generated from their use of these materials. There are social interactions, issues around trust, equity, ethics, inequality, social support networks. All of those things need to be considered in terms of what happens around the world. And obviously, for some people, they don't necessarily see that as a web that it literally extends around the Earth. Earth systems themselves, climate change is the classic example. Ecosystems, of course, are that balance where things that we do in one locality can impact the rest of the world. Climate change is obvious example. Acid rain, power plants in the Midwest impacting, states in the East. All those things show the interconnections of the things that we do. And then, of course, governance. What is the performance of governments themselves? How do they essentially organize themselves? How do they regulate their societies? How do they interact with different members of society? And of course, business. Business has governance responsibilities in terms of how it conducts itself, what it pursues, and how it essentially goes about its business, so in an ethical, hopefully ethical way. So complex systems obviously require complex thinking. So it's not necessarily a simple solution. It's not a single idea that essentially can exist. You need to be very thoughtful about looking at all those different interactive parts and finding out what can be done with all of those. Complexity, how do we deal with poverty in the midst of plenty? If we looked at averaging all the incomes, we would probably be a few $100,000 for each individual person in the US. So big question mark as to how we can address this. It defies a single solution, a single diagnosis. So doctors know a fever has many causes. It does require a differential diagnosis. There could be some, competing issues in here. A skilled sustainable development practitioner needs to conduct sometimes a specific diagnosis for each case and each component, but also recognizing that needs to be rolled up into a much larger review. And again, you acknowledge the complexity. So technological change, we do have to understand sort of three key aspects of technology. One, of course, is that it has been the main driver for long-term global economic growth. And since about 1750, we've experienced relatively significant technological advances, from steam to internal combustion to electrification, chemistry, agronomy, aviation, nuclear power, information systems. All of these essentially have moved not just the way we interact with each other, it's moved the way we essentially have been able to increase and improve the economy. Our standard of living has improved, although it's been at the expense sometimes at the degradation of the environment, which has its other problems. And of course, then we also have the concerns about our chemical body burden. So there are trade-offs in all of that, but nonetheless, it is seen as an improvement in terms of economic growth. And without these changes, population increases, economies wouldn't have essentially expanded as they have. Transport's moving from clean, low carbon energy systems. It's just an example of what could be done here. Now, obviously, I've also mentioned that technological advances have negative side effects. We started burning coal, we recognized there was air pollution, health effects, acidification, localized environmental effects, global effects in terms of climate change. And if we continue to use coal, of course, the damage to us is just going to be catastrophic. So we need to acknowledge that that's a component. The third is that this just doesn't happen. It does occur through human guidance. And the perceived drivers are sometimes just luck of the draw. Skill of individual inventors, it's the response to demands of the marketplace, or it's directed by goal-based interactions of public needs and private R&D efforts, health research, military, all of those things are seen there. But nonetheless, we have control over this. It's not something that just springs up, and which is why there needs to be some thoughtful review of products as they come about. It's not just because we can do something, we should do something. It is that, again, an interaction of our governance efforts in terms of what should be done in this area. So the other, of course, is just the speed of change. we've seen, again, technology really rapidly increasing, sometimes to the point where it's very difficult for people to, if you will, keep up with that change, to recognize, that new skills are required and the old skills are no longer necessary. And that's very painful and very difficult to essentially accept. The technology, of course, impacts certainly now almost every facet of our lives. Now, I, I should note here the issue of systems. And our society does require an awareness of the broader technical systems which products and projects are embedded, defined as a holarchy. So again, a car is a single component providing private transportation, but the car then allows for pollution. It does allow for sprawl. It does allow for a certain anonymity of individuals who are isolated from each other because of this. So there's issues around the social fabric, there's issues around the environment, issues around the impact on biodiversity, impact on land use. All of these things are part and parcel of the holarchy that exists around the car. So clearly we are facing unprecedented, rapid and accelerating technological growth. Everything from biotechnology, nanotechnology, robotics, IT, communications. And those things are going to have implications in terms of things like jobs. The jobs that were available in the past are going away. And the question mark, of course, is what's going to take their place? And so this becomes an issue. Now, this is just an example of the waves. And you can see that the change in terms of different types of innovation, different types of technology, and the length at which they were dominant is declining, is decreasing in terms of time. So everything from 60 years, starting with, again, water power, textiles, to steam power, now, of course, to digital networks, biotechnology. All of those things are part and parcel of the waves we see, and they're just going to continue to grow as we continue like this. Also, the speed of introduction has declined. Things are happening much more quickly. It took a long time, again, for cars to really come into their own, for telephones to essentially be adopted. But now PCs, cell phones, the internet are happening literally with the span of a decade or two. Now, the other component of this, Garrett Hardin of UC Santa Barbara, back in 1968 in Science magazine, indicated, of course, that society allows a certain freedom of activities that, without regulation, will allow for the adverse impact to those common areas. Overgrazing, overfishing, overlogging. The classic example, of course, is cattle in the square. If you're allowed to bring your cattle into a public area, you will continue to maximize the number of cattle you have and the consumption of the resource, the grass in the commons, to the exclusion of all others, to the point where it literally is overgrazed and no one can use it. Overfishing is the same way. You continue to fish and fish and fish until the fish are gone. You'll cut down trees until they're gone. All of those things are out there. Harvey Brooks of Harvard essentially talked about the convenience of the private auto and how that encourages individuals to use it for all their transportation. And that's fine if you have low levels of traffic density. When the cars were first being, if you will, rolled into society, not everybody had a car. And so therefore, the number of cars in the road, when I was young, was very low. You didn't have, the sort of traffic jams, the snarls you have now. Now, of course, you have that situation where what had been a benefit in terms of your freedom, your private ability to move from one spot to another is now curtailed. You're caught in a traffic jam. You're wasting time. You're burning resources. You're polluting the air, and you're really not getting anywhere. Whereas public transportation might be an option, and that's true for the major cities around the world. That's not just, of course, a U.S. phenomenon. So the commons themselves impact air, water, land, and public and environmental health, aesthetics, and necessary waste are all part and parcel of what happens when we exploit those commons. So it talks about the relationship of industry, society, and of course the impact that it has on the environment. Free riders are those people who use resources but do nothing to sustain them. And the classic example is overfishing. One of the success stories, of course, was the use of, or the elimination actually, of CFCs through the Montreal Protocol. Now, there are, again, hidden issues here. There are other agendas. Some of this came about because DuPont, who was the originator and manufacturer of CFCs, found an alternative. And so they fought this for many, many years until, of course, they found an alternative, and then they literally pulled back and said, fine, let's go ahead and eliminate the use of CFCs. We'll use HFCs instead. And that allowed, again, the success story that we talked about here, the countries coming together, but it was really driven by the power of one company, which was extraordinary. Troubled issues is climate change. Again, same sort of thing. You know, the petrochemical industries are going to fight and fight and fight this because it means their demise if we do anything like use renewable energies. Now, if they are then part and parcel of that renewable energy technological wave, then we, just like with DuPont and CFCs, we could see this turn around very quickly. So therefore, impact of industry is significant. The level of scientific uncertainty in some of these issues can be problematic, especially in political circles. And certainly the long time scales that these things sometimes come to fruition, to materialize, can be a problem. And it really does impact our ability to properly manage it. So technology clearly has benefited mankind, but there are problems. The difficulty of absorbing pollution, especially around those compounds that are anthropogenic. Things that are natural in origin tend to have the potential of being assimilated in the environment. Anthropogenic compounds, there's no ready organism that can break those down. They've been developing, but they're still problematic. Increasing consumption of materials and energy in an unsustainable fashion, the linear economy, which is clearly something that we're going to be focused on in this course, is just not something that can go on for a long time. We have to essentially reduce our consumption and work on the circular economy to avoid just this sort of thing. Energy consumption is moving towards secondary, i.e. electrical consumption, as opposed to direct fossil fuel use. But as I mentioned before, we need to be thoughtful then about how we generate that electricity in the first place and move away from fossil fuel use. And then, of course, this has been aided in the explosive growth of mankind. And again, this is a situation where there is a synergy of sorts with the increased new technologies, new materials, new affluence. We have the increase in population. But of course, with the increase in population, you have a demand for more materials. And so this goes back and forth and becomes perhaps a downward spiral. But again, tenfold increase in the population since 1700. So 3 different possibilities for the future. And this, of course, is really what the class is all about. Managed growth. We can continue to grow until a long-term sustainable mix of population, technology, and culture is achieved. A steady state economy, no growth. Of course, what does that mean for a lot of other issues? It's yet to be determined. But nonetheless, this is one approach. The other is a managed reduction of population to lower sustainable levels with less technological activity. Now, this one, it's not a managed approach, but clearly that's what the UN is doing with their Sustainable Development Goal #1. Alleviating poverty. Again, something that's almost ethically and morally required of us to do on its face, also has the other agenda of reducing the population as people become more affluent. So interestingly, have fewer number of children. You would naturally think that it would just be the inverse of that, with more affluence, more children, because you can feed them. And in some societies, that is the case. If you ask, mothers in certain areas, what they want is more food so they can have more kids. So that connection doesn't always hold, but for the majority of countries, it does work. The third, of course, is the apocalyptic view. It's an unmanaged crash. We continue to grow in terms of population, in terms of consumption of resources, until the population dies off. Resources essentially come to the limits, And of course, then you'll have a readjustment of the set point. You'll have a smaller population of the planet. They'll live, more simply, or to be fair, um, in a much more disadvantaged way. It will not be the same level of standard of living that we currently have. And that, of course, is a concern. So therefore, the implications are if we continue to use resources as we have, we're just not going to be sustainable. We're going to have a crash. So therefore, a different approach is required, which is probably some combination of managed growth and some natural reduction in population due to an increased standard of living, but that has problems as well. Now, Chernow back in 2001 came up with a concept, not an equation, but a concept. And he said, look, the impact of society on the planet is a reflection on the number of people we have, the population, the affluence, i.e. the consumption per person, GDP per person. And then of course, T is the technology impact per unit of GDP. It is, does the technology allow for more consumption with a lower environmental impact? And again, that's sort of what we're trying to get at with respect to industrial ecology, trying to eliminate waste, trying to maximize the use of resources. Hopefully, along with that, we'll come back and also have products that are not necessarily harmful to the environment or to us. Now, as I said before, it is conceptual. It's not a mathematically rigorous equation. It's used to suggest goals. It doesn't place all the blame on population, but you can see there's some things that are just going to happen naturally in this equation that have a certain impact. And that, of course, is we expect the population to increase, perhaps by 50% by 2050. So we'll go from 6, 7 to 9 billion or 10 billion by 2050. The affluence, again, to get people out of poverty, that means this has to increase by a factor of somewhere between 2 and 3. So the only variable that we really have any control over here is going to be the technology. In order for this to be steady, the impact per the unit of technology is going to have to decrease by 65 or 80%. And that's why if you see different articles, they talk about a factor 10 or factor 4 in the technology impact, again, the environmental impact per unit of economic activity. This is what they're referring to. They're referring to the need of being able to do this. So it becomes important. So of course, the classic question is, what do you think is going to happen? Will it be managed growth? Will it be managed reduction of population? Or is it unmanaged crash? I think most scientists, most regulators, most academics seem to feel that we'll have to go into a state of managed growth. But we also have to recognize there's a significant component of the population that would very happily continue to march to the edge of the cliff and, like lemmings, jump right over. And so there is the potential for unmanaged crashes if, again, the people who are unaware, who refuse to believe the facts that science provides, could essentially continue as they have and force everybody else in that same path. So this is the challenge for us. We really do have to think about how we educate people, how we bring them on board, and how we all essentially recognize the need to work collectively in this area. So you can be driven by peaceful purposes. Clearly, we have government support, mostly hopefully for civilian technological advances. But when we look at a lot of the changes that have occurred, they come as a result of military investment, which is frustrating, but nonetheless, it's just the reality of the world. Hopefully that can change and we can start to divert some of the resources we've been putting in the military and putting it more directly into civilian technologies. Future of sustainable development, of sustainability. What will be the government intervention in terms of transport? Will they encourage public transport? Will they generate public transport? Will they put in infrastructure? And will they deal with the issues around construction here? Will we be able to feed people so people don't have to be food insecure? Will we provide education across the board? Will we encourage people not just to get university education for the select few, privileged few, but will 20, 30%, but for that 70 or 80% of the population, will there also be alternative educational systems that allow them to participate in these change technologies that we just talked about. Now, there are public policy tools, there can be public financing of R&D, there can be direct research in public laboratories, regulations, prizes, awards, patent laws. All those things are policies that help define and direct what's going to happen. So, in terms of environmental threats, we have a significant list. Obviously, the first and foremost is we're changing the Earth's climate, and that is going to be catastrophic, throughout the world. It will create inhabitable areas that where people are currently now, and it means that if they're going to survive, they're going to have to migrate, and that creates its own problem. So we have issues around migration, food, just general ability to live, and the ability to maintain our standard of living. It's going to be tough. Depleting the availability of fresh water, not just because of pollution, but because of, again, climate change will sometimes make water either too abundant or too scarce. We'll have droughts or floods. Neither one, of course, is particularly helpful. Modifying the ocean's chemistry. Again, with climate change, you see the decrease in pH because of CO2 addition from the atmosphere, but we're also changing it because of things like plastic addition to the ocean. We're seeing, again, the Pacific Year, where you have this just rolling mass of plastic that's been concentrated in the Pacific, and it's essentially becoming part and parcel of the bodies of aquatic organisms, as well as killing them. So we're despoiling their habitats in that way. We're despoiling the habitats on terrestrial systems. We have a lot of environmental threats that we have to address. Some of those are connected, and as I mentioned before, if you can listen to some of this, you recognize the interconnection. These are not standalone issues. They're issues that are driven by a system that essentially is created by people. It's anthropogenic. And we have to make sure that our anthropogenic system does not destroy the natural systems that are out there. So it's a real challenge, and very complex because, as I said, these are interactive. So changes in the water, nitrogen, phosphorus cycles. We don't know the precise timing or the implications of changes, but we know they can essentially impact our ability to live on the planet and impact the last 10,000 years of civilization, of people essentially coming together to live in villages, towns, cities, and forming societies. So with that, let's talk a little bit about the legal and ethical issues in terms of how we deal with products and systems. Governance, of course, is the process by which societies implement their values. The most important governance mechanism is the nation state. They're the ones that essentially generate laws. They can recognize international laws, but obviously at the end of the day, they're sovereign and either voluntarily or involuntarily or reject those opportunities. And they have jurisdictions within their borders. So again, complexities arise. When we go from just an environmental problem, dealing with end of pipe problems, to sustainability, which are far more complex and more of a systems approach. So how do we integrate environment and trade policy? How do we view barriers to trade by developing countries? Are we going to allow them to use dirty technologies so they can essentially rise to the level that we currently enjoy? All those are really difficult questions that need to be addressed. And of course, naturally, governments influence the behavior of companies. The struggle to govern the commons recognizes that we need to be adaptive. We need to have transparency and provide that information. We have to deal with conflicts here. We have to have some level of compliance. We have to provide some level of infrastructure, and we all have to be ready for change. And all of those essentially are going to be very difficult challenges for society to address. So the tools that government has at its disposal, clearly there are sort of the command and control directives, bans, standards, regulations, all of those things are forcing mechanisms from government to essentially tell companies what they can and can't do. But on the other side, we also have issues around incentives, permits, taxes, subsidies, awards. Things like that essentially can drive the discussion in a way that can be very positive. The tools, of course, that can be used in terms of evaluating conflicts and sometimes distortions. There is life cycle assessment, environmental impact analysis, labeling. Uh, there are efforts around transparency that I personally see as very positive. Not just audits or green accounting or R&D investments, but sometimes just fundamental information on activities. SARA Section 313 required reporting of toxic substances to the environment. Just that reporting caused companies to start to think about that in ways that were different than they ever had before, and they ratchet that down. And I'll talk about my own examples there later in the class. And awards, making sure people are recognized for their effort. This seems trivial and almost too mundane to even be thought about, but nonetheless, that sort of recognition can drive good behavior. This is just a chart that I saw, a figure that I saw, that goes from forcing mechanisms to changing incentives to providing transparency. So you go, again, as I said, from bans to regulation to audits, information campaigns where you make it available, and rewards and recognition. So it's a spectrum that you need to think about with respect to what government does. And you don't want to look at these things in isolation. You have to recognize that all of these things need to work together in order to affect change. And also, I'm not suggesting, by the way, that regulations in themselves are bad. I have always found that having the barking dog in the corner can sometimes motivate good behavior. But I wouldn't limit it to that. You need to understand that sustainability, certainly, and industrial ecology is going to require innovation from the company. And that innovation usually is not always driven by a command and control approach. It needs to be driven by allowing for flexibility and allowing for creativity to essentially flourish in these circumstances. So obviously sustainability came out of environmental concerns. End of pipe treatment technologies were recognized as being limited because they're an overhead cost for companies or for society or for communities. And so therefore the idea is to find ways to, if not eliminate, certainly minimize those, with of course the goal is eliminate the impacts. And so therefore having a much more sustainable and resource efficient approach. The other ones of course are going to be how you deal with the present and how do you deal with the future. How are you going to provide for intra-generational equity? How do you regulate so there's some level of comparable equity across different parts of society, across different countries, different parts of the world? You also have intergenerational equity. How do you regulate for the future? Do we overfish right now, have fish for our plates and have nothing for our grandchildren or great-grandchildren? That doesn't always work. We need some level of flexibility, the tension between stability and need to change. And as I said, a better approach, you need regulations, but a better approach is to give a certain level of flexibility. And that's a clear distinction between what happens in Europe and what happens in the US. Europeans tend to be much more collaborative in this area. They weren't always that way, but I think they've learned that's necessarily a better approach. For any number of reasons in the US, that evolution has not been allowed to occur. And the other thing you need to think about, certainly for companies, is that current decisions lock in future options. So as an example, I pointed out incineration. By putting in incineration, you've made that investment. That essentially precludes the ability to go in and recover and recycle and reuse materials. You've already paid for it. Why are you going to pay again to essentially have that incinerator sit idle when you're recovering and reusing? And again, sometimes the cost implications are so significant that it just doesn't work. So the other, of course, is just the regulatory structure. And again, it's an issue between simplicity, complexity, and political resistance. And sometimes, you have to define what is the appropriate jurisdictional level. Now, in many countries, unfortunately, around the world that were former colonies of European countries, they're living and dealing with artificial boundaries that were drawn by their European masters at the time that don't reflect the natural, if you will, groupings that have occurred in those countries. And so therefore it creates their own tensions, And that, of course, translates into international concerns as well. For intra-generational equity, political science, of course, is the classic definition of the distribution of wealth between haves and have-nots. It is highly contentious. It clearly defines the philosophy and the ideology of whatever party you want to name. Some opposition to sustainability derives from the idea that it's a backdoor way of redistributing wealth, primarily from the developed to developing countries. And it is a consideration in international treaties. So it does exist, and we need to be thoughtful in terms of how that works. For intergenerational equity, some traditions recognize the concepts of fairness between generations, the stewardship of our resources. Practice, however, is not so good because there's no one literally arguing for future generations outside of your own feeling for your children and subsequent generations that come from that. So legal tools were developed primarily when we were in a period of at least of understood or aware unlimited growth of resources. Resources were seen as infinite. And we also, in the same token, the pollution capacity was also seen as infinite. The other component is that future generations weren't seen as having rights or standing because there was no defined interest. We really don't know what they need. We don't know what it's going to look like. We don't know what technology they're going to rely on. So it's hard for us to know exactly what to preserve and what not to preserve. At least that's the argument. I don't particularly adhere to that, but nonetheless, you'll hear that from a lot of people. So therefore, the issues are going to be global in nature. And in many cases, sometimes it does become difficult to assess the impact and risks on specific countries and specific stakeholders. You may do a broader brush scale, but the actual impact on a particular country for the long term can be difficult, not impossible. And climate change has done that. We do know that if we continue on the path we have right now, there are certain countries that are just going to be uninhabitable. It'll be too hot and too inhospitable for people to live there. So it's not an impossible task, but nonetheless, it's one that's fraught with conflict. So in terms of an approach, we need to essentially think about what we can do for future generations. And Edith Weiss came up in her book, In Fairness to Future Generations in '89, with 3 basic principles. And one, of course, is conservation of options. Don't foreclose on resources. Make sure we use those resources sparingly to make sure they're available, especially those that are already sustainable. Forestry, fishing, biological systems. Make sure you don't necessarily squander that. But also others, but I'm afraid they're going to happen. Conservation of quality. Each generation should have the same quality planet. And of course, that's an issue around issues involving biodiversity. We recognize that the aesthetics, the biodiversity, the quality of life is just going to be different in the future because of what we're doing today. The third is conservation of access, making sure we have equitable access to the global legacy. And that is, of course, making sure that no one country or one set of countries, again, the global north versus the global south, is somehow inequitably favored for the future. And so therefore it is a question of access. And this one's difficult because obviously the only way we do that right now is through economics. And that again becomes a catch-22. How do you improve in your situation when you have a poor economy? And how do you improve your economy if you have a poor situation? So it just goes into a negative and downward spiral. So the implementation is usually in the courtrooms. It is interpretive case law applied to factual situations. We do have some international tribunals. They've had to essentially deal with some of these things. But again, this is not one where there's been a great deal of growth and progress. Flexibility, laws are usually conservative and inflexible. They tend to defend the status quo. And of course, there's a classic price for this inflexibility. Command and control regulations are only applied to emissions where we need to consider the process. So we have technology-driven regulations, which essentially reflect limits in terms of what can be done. So we might identify what needs to be done in terms of our public health, but usually that's tempered by what we can literally afford to do and still achieve a certain output. So you balance the public health and the common good, if you will. At least that's the argument. And of course, this encourages those groups that benefit from continual regulation. So anyone who is involved with waste, again, from an industrial ecology standpoint, wouldn't want that waste to go away. And that, of course, is our objective. This is going to be something where, this ox is going to be gored. We do need flexible regulatory tools. As I said before, the Netherlands is a good idea. Europe really, in general, tends to move much more toward a flexible approach to environmental regulations. But they weren't always there, as I said. They had come from a very inflexible state to recognize there was real benefit. So part of this requires transparency, measures that can evaluate performance. They need good metrics to essentially assess what can be achieved, and then of course how that impacts the public health goals. The process has to be explicit, and the legal structure has to allow for a bit of give and take, a lot of discussion that essentially winds up being defined as a negotiation. So the regulatory management structure here, you have a boundary and a target intervention. Boundary laws are going to encourage appropriate behavior. Climate change, energy reductions, try to be more efficient, trying to encourage that right behavior. Targeted are bans, ban on lead and gasoline. They have a very specific action, and it's a dictate. It's really a demand that government places on society and on different companies. So the evaluation criteria, is the impact significant and difficult to reverse? And if so, it can be sort of targeted. If it is easy to identify and control, also it goes to the targeted, dictated approach. If the impact is really broad and unclear, diffuse, no clear technological fix, you can use boundary conditions. Then of course you also have centralized versus decentralized regulation. It makes no sense to ban city levels of CFCs. It's symbolic, not always enforced, because it's not something that they really can regulate because they don't make it. And it does negatively impact other laws, because if you have laws in the books that you don't enforce, it erodes the level of adherence to the ones that you do want to enforce. If the impact has crossed boundaries, it should be legislated by an entity that exists in that level. So if it's, again, acid rain, we had a situation where in the Midwest, power plants were emitting acidic compounds that essentially washed out into the northeast, causing acidic rain, acid rain, causing deforestation in that area. That can be regulated at the national level. If, however, it's global, that has to be regulated at a global level, perhaps the UN through the different protocols. Now, if the impact is local, it can be legislated at that level. However, there's historic difficulty with that. And that's sort of the origins of a lot of federal environmental laws back in the late 60s, early 70s. And that is that because of local interest, a lot of pressure groups, a lot of money essentially moving back and forth, localities and states were unable to properly regulate these areas. The federal government really was the only one that had the might and the power to essentially impose their will in these areas to cause change. Market mechanisms, I think, are very positive as long as you can properly cost it out. And if you can't, you can either overdo it or underdo it, and that causes its own set of problems. So we'll see where this goes. Obviously, it has been debated in climate change in terms of whether or not we want to have some sort of mandated price of carbon, sort of a carbon tax, which of course can be regressive. Sort of the poor have to get around. Unfortunately, they buy older cars, they have older cars or big trucks, and they can, not necessarily be very efficient. So therefore, their carbon tax could be substantial. And again, very, very repressive in terms of their situation. So we need to think about that more broadly than just a carbon tax. You also have to have some level of subsidies, perhaps for the poor, to sort of move them out of that, move them into a more positive energy efficient mode of transportation, public transport or cheaper electric cars perhaps, but also recognizing they have to be subsidized in order to accomplish that. Jurisdictional levels, of course, are in there with industrial ecology. Uh, Political jurisdictions are just a creation of our history and our culture. They don't necessarily reflect natural systems, and so therefore you're going to have this disconnects. Um, Industrial behavior, usually not geographically or even jurisdictionally co-located with the pollution. It moves away. So therefore you can have pollution shopping in terms of where you're going to put your manufacturing facility. This is, of course, the issue with globalization, facilities moving overseas. So therefore, as a result, you need both vertical and horizontal harmonization. You need to essentially link up the policies and jurisdictional hierarchies, but you also need to work across those jurisdictions to make sure that there is some broader effort and to avoid the issues of symbolic laws that aren't enforced. Trade and environment, you need open international trade as an economic policy, but with this you have the potential to have goods that are manufactured in very unacceptable means. So the environmental community looks to restrict those goods that were made by pollution-heavy industries. And sometimes it is co-opted by protectionist groups. It becomes its own trade tariff that can essentially impact us. So there has to be some other mechanisms to deal with it. Now, environmental restriction should be neutral. Certainly the benefit needs to outweigh the detrimental impact on trade. And the restricted good should be able to achieve the desired environmental goal. You need to be able to understand how that is accomplished. Again, easy for me to essentially link these three, but to achieve it sometimes can be a challenge. So it also essentially erodes the absolute primacy of a nation state. There are countries, of course, where child slave labor occurs, and those countries aren't necessarily doing perhaps what they could or should to address it. So therefore, there comes an effort of international law of influencing those countries, which of course, as I said, erodes the primacy of the nation state. For consumer protection, usually you want a full disclosure of the properties of the product. It inhibits the use of recycled materials, even if they meet the specs, because some people are squeamish about that. Why would you want to buy a new car that's made of recovered and recycled materials? We found that can be done, but it requires a little bit of awareness and education. Short term, based on specs only. Long term, as I said, there has to be some type of education here. You have to understand that, what you're really achieving. And some discussion has been on the functional economy, that really what you're purchasing is a function or a service. And so therefore it can drive yourself into the sharing economy, where you're leasing things, you're leasing cars, you're leasing Xerox machines. So you're buying the functionality of that unit, not the item itself. The other issue you need to focus on, you need to be aware of, is the impact of big company specifications. California does this with car emissions. Because they're such a big consumer of cars, they literally are the 800-pound gorilla that controls what happens in the rest of the country. The military does the same thing. Mil-spec is just that, it's military specifications. It can be a barrier to change, or it could be a powerful agent of change, but we need to make sure it is open and flexible in terms of moving forward and progressing and allowing for modification. So obviously you need to find, and all of us, find the right solution for economic and environmental needs. Brad Allenby, who obviously wrote the book that we're using, and I think really a good guy, he was the EHS VP at AT&T, recognized that antitrust looks to maximize competitiveness, and sometimes environmental initiatives can do the opposite. And again, we're talking perhaps about the circular economy here. So therefore, the idea is that the initiative is to expand the scope and the scale of the firm. It can control material selection. It does control consumer use. And of course, it impacts on take back. And that take back influences what you do with refurbishment or recycling. And so therefore, antitrust wants a competitive market with low barriers to entry. But if you already have a post-consumer lock on takebacks and the number of technical choices, the number of companies that are out there are limited. And essentially, if you will, fossilize the existing power structure of industry. And of course, this is almost a theoretical argument. I'm not sure we're even there yet to worry about this, but he's looking forward. You need to do that. And of course, the solution to this requires a very sophisticated approach that doesn't exist quite yet. Although I can see signs of this in Europe, where their waste directive does require trade associations to be part and parcel of the take back initiative. And so each member company of that trade association makes a contribution to ensure that a organization, another company, collects that material and gives it back. Not exactly a reverse logistics approach where individual companies go out and do it, but nonetheless, it's a way by which smaller companies can join the trade association, make their contributions to the take back program, and benefit from that too. So there are solutions out there, and I think the Europeans are leading the way here. So there are a generic set of design for environment guidelines, and here are a few. One, of course, is you choose readily available materials, you minimize or avoid hazardous materials, you minimize materials diversity, you minimize energy and resource consumption, you minimize the buy to sell ratio, you minimize product weight, and of course you use recycled materials whenever possible. Continues on, you want to use environmental packaging, environmentally sound packaging. You want to minimize the energy use and material losses in use, and there are a lot of different examples for that. You want to inhibit dirt, wear, and corrosion, extend the product life, so you need to make sure that that is somehow protected so it doesn't allow for things to literally give up the works. You certainly want to encourage upgrade, repairs, and remanufacturing and recycling, sometimes through accessibility, module development, breakage points, manuals, designed for disassembly. Far too often things are literally sealed shut and there's no way to break it apart. But so the idea here is that you'd have little screws in the back, pull it out and take component parts out and possibly reuse them. Avoid material combinations. Alloys are the classic example here. You have an alloy, it's very difficult to recycle because you have those two metals fused together and you can't break them apart. So you need to be thoughtful about what you do in that regard. And you apply all of those things to your supply chain. So it's not just what you do to make your product, but it applies to the supply chain. And this is a common diagram that looks at, if you will, the circular economy with respect to, again, reusing, remanufacturing, recycling, recovery, and reformation. So this is, if you will, a template for what you want to do to consider the circular economy. So, systems analysis. The systems analysis for industrial ecology, of course, we address long-term habitability. It examines regional and global scope issues. It focuses on the scale of human activity, certainly where it overwhelms natural systems. It should protect resiliency of natural and human systems. It does use mass flow analysis, and it does look at economic production agents, i.e. private firms, to mitigate those environmental impacts. And we talked about holarchy. I want to reinforce that because this is a concept I want you to come away with. And that is that there are, literally rings within rings, wheels within wheels in this regard. There are ripple effects of the use of a given product. So cars are out there, it helps with mobility. It does impact in terms of resources. It has the environmental impact we talked about before, land use impacts, and social impacts. Spread, suburban sprawl, employment, community development, separation, alienation, all of these things essentially derive from this one single product. And that's not alone. There are other products that have the same effect. We can talk about perhaps iPhones in terms of what impacts they have within their holarchy. So the idea, of course, is we need to predict and plan for the future. What are the global estimates out there? What tools do we use? Do we use modeling? Do we use scenario development? And the examples are two major reports in terms of limits to growth and our common future. We'll talk about that in a second. The classic industrial example will be long-term strategic planning, where we have phases of going for 20 years or more, 40 years. This is new, to be honest. Companies usually don't think about that. If they have a 10-3-1 plan, a 10-year, 3-year, 1-year plan, it usually is a 1 year with a lot of detail and specificity that essentially is multiplied by 3 to get a 3-year plan, and with some vague thought about what happens in 10 years. Now, for some companies, they really do have to have a much more specific long-term goal. If you're making airplanes, pharmaceuticals, products that essentially have a long research and development life, you need to be much more thoughtful about that. And with systems analysis, that comes into play probably more frequently since about 2010. So the industrial ecology models are out there. You look at the transformation of materials and energy to produce the products. You look at the transformation of materials and energy to not just produce them, but also to impact their use. And then beyond that, your class 3 model would be to look at class 2 plus behavior, how people actually use your product, what implications that has. And again, sometimes people don't use the product in the way you intended. So you need to think about that. So for scenario planning, Shell uses this quite a bit. You look at the existing condition, you make an estimate in terms of number of different choices you have, and if possible, you select the most likely outcome and work to that goal. The examples, as I mentioned before, limits to growth was, again, the MIT modelers got together and said, if we look at resources, population, waste impacts, what's the future going to look like? And they ran it through their models. And of course, they came up with scenarios whereby 2050, we could have some limitations on resources. Naturally, for their efforts and for the troubles, for the good work, they were punished. They were really beat back by the politicians and even other scientists. Again, no good deed goes unpunished. For Our Common Future, Gro Harlem Brundtland in '87 did something a bit different. She did more scenario planning. She was much more engaging with people literally around the world. And her rhetoric, her outcomes were much gentler. They were more sort of common sense. So the classic definition, of course, is we act in a way today so as to not adversely impact the future. That came out of Our Common Future. And you can see that sort of general approach, just as easier on the ears and easier to comprehend. Now, in companies, obviously, it's broken down into silos. You have R&D over here, manufacturing here, sales and marketing there, legal groups over here, environmental groups over here. They don't necessarily all join up easily. And so it's always helpful to look at the interplay of those different functional and operational groups. Obviously, they're all there to carry out the mission. So it needs to be more and truly a systems analysis. Now, if a company really has a lot of foresight here, the company can examine the implications of its actions on society. And so cars, again, a classic example, would the manufacturers of automobiles be more thoughtful? Would they understand the economic sustainability issues in terms of the engines they use, the types of cars they use, or public transport? There are apocryphal stories about companies actually going out and buying public transport companies, especially around Los Angeles. And they said that was really what GM did in order to push a car culture into California. And of course, you have to look at the economic impacts in society from your suppliers, your facilities, your dealerships, your gas stations, repair shops, roads and bridges, infrastructure, all of those things are out there. The environmental sustainability issues in terms of all aspects of the supply chain, public health issues, emissions, all of those things are out there. Social sustainability, would the manufacturers understand the issues around consumption, employment, commuting, the built environment in terms of cities versus suburbs, the social interactions that essentially are implicated and impacted by the availability of cars. So that's essentially a discussion on systems. A lot of information packed in there, and I recognize that. Design for sustainability, it really is just a mechanism by allowing companies to look at different options and hopefully better options, either in their chemistries, their processes. All of that essentially helps with, again, the design of the product, which is really what we're focused on here. The other issues we'll talk about in more detail later on. Life cycle assessment gives the implications of proposed decisions. So it looks at different boundary conditions, gate to gate, cradle to cradle. It looks at different subsets. So it really is a very simple effort of looking at inventory, inputs going into your process and outputs. The difference is it goes compound by compound. And so it becomes a massive, massive list. And then from that, you look at the impact assessments, from those outputs and also the inputs. What's the overall impact to society? What's the impact of the planet? And that, of course, is the strength of doing a life cycle assessment. The other is, it's a little simpler, gentler, but it has a lot more profound implications for what you're doing. And that is stakeholder involvement. I have done that in the past in Europe and in the US and other parts of the world with real benefits in this regard. And that, of course, is that you get these people together who are impacted by what you do and ask them to comment on what you're doing. And again, if you set the tone of that properly, if they understand that you're serious about wanting to engage with them, you can look at their recommendations very positively, and they can look at that as an opportunity for them to influence what you're doing, that hopefully will minimize the impact on them. So you have this nice interaction that can occur that can be very positive. Of course, they can all go very wrong if you manage it improperly. So how does a business model impact design? We talked before about buying and purchasing and owning versus service economy. And so it really does essentially make a difference in terms of where you're at with respect to your business model, in terms of how you design your product, how you develop it, how you bring it back. So if you're in a service economy, obviously you still own that piece of equipment. It's going to come back to you and you have to refurbish it. So therefore, you're going to be a lot more thoughtful about how you put that together and how you can fix it than for a product just going out there and you'll never see it again. And of course, the third step is one where the product does go out, but you're going to recover it through a circular economy approach, reverse logistics approach. All of those things are considerations with respect to the model. Now, the design itself, this is really what I want to get to. Since the Industrial Revolution, there are a number of things that I think we have to at least appreciate. The relationship between companies and the environment was just a question of transactions, activities. We either extract materials or we just dispose of waste in the environment. That was it. The assimilation, the resources were seen as limitless. Industries didn't recognize that they operate in a web of industrial systems. I think they saw themselves as standalone. Materials, either inorganic or organic. The disposed product usually winds up at somewhere back in the environment. Landfills, incinerators, in the air, dumped on land, air, water, all of those things are, what happens to your product. Again, it's conservation of mass and energy in this regard. And of course, the classic historical focus is always to meet the needs of the customers. And as a result of all of the things we just discussed, companies were not always very good about recognizing the consequences of what they were doing. I think they're getting better. I think there can be long-term, but they need to think about this. And here's a good example. Dr. Way at Princeton came up with identification of products that met the needs of that particular point in time, but then had negative consequences later on. So chlorofluorocarbons, it clearly was a replacement for ammonia as refrigerant. Ammonia had problems with flammability and explosions. Chlorofluorocarbons were stable, steady, safe, easy to use, non-toxic. Seemed like, again, a classic, wonderful example. Interestingly, there are a couple of common inventors for these. So this was Thomas Midgley. Of course, now we know the chlorofluorocarbons eroded the ozone hole, causing problems with skin cancers, more UV rays. All those things are a part and parcel of it. So that's today's problem, because they didn't understand that implication when they made the product. Tetraethyl lead. Now, this one, I would almost give Midgley a buy on chlorofluorocarbons and not really understanding it. But putting lead in the gasoline that you knew was going to essentially be run through an engine and exhausted into the air that people would then breathe in, I don't cut them much slack on that one. We understand that lead's going to come out of those car exhausts. They're going to find their way into the air, into the soil, people, especially children, and they're going to have impaired mental ability because of that. And it just has that effect. Mosquitoes and malaria DDT, it is, of course, was seen as a savior for people, certainly in tropical regions where malaria is endemic. Now, it's interesting. The battle here has always been that we were literally trading off the impact of birds and mammals against the needs of humans. And in this one, birds won. And the reality of the situation, however, and of course, it won't be necessarily always apparent depending on the article you read, but the reality was that DDT actually was becoming less and less effective in terms of knocking down mosquitoes. Mosquitoes adapted to it, and malaria was just at a point where there was no benefit from it, so it gave it up. Of course, with its ban from that, because it wasn't effective, it also had real benefit to birds and mammals. Now, I'm not saying that there weren't people out there actively, making an effort to ban DDT because of its impact on birds and the degradation of biodiversity, but nonetheless, the other side component here, and this gets back into more broader systems analysis, was that the species evolved to deal with that particular pesticide, so it wasn't quite as effective. Now, the other one, and this is Fritz Haber, and he has an interesting impact on the world. Back in the 1920s, he developed a process to develop nitrogen fertilizer from air. Nitrogen is a big component, need a lot of energy, but nonetheless, you can capture that nitrogen, transform it to a nitrogen fertilizer. That really exists because of that, that product. Probably about a third of today's population is allowed to exist. There wasn't sufficient fertilizer for food production for, again, our 7 to 8 billion people that we currently have. Indeed, and one of the things that really sparked Nixon's trip to China was that the Chinese were having famine problems and they needed more fertilizer in order to grow food for their population. And so one of the things he offered as a trade in terms of better enhanced relationship was the technology to build those fertilizer plants. Unfortunately, Fritz also had a negative side. He developed mustard gas for the Germans in World War I and Zyklon B for killing Jews in the concentration camps and their gas chambers. So it's, his history is not necessarily untainted. His wife killed herself because she couldn't live with the knowledge that her husband created that. So all those are way of background. So we do have a situation where we understand that products meet a certain need for the day, but create negative implications later. Of course, with nitrogen fertilizer, its overuse causes lake and estuary eutrophication. So we can't necessarily avoid that. So old thinking for industrial planning, industrial systems, and natural systems are essentially independent. The new thinking is that industrial systems are located within natural systems, not necessarily because of a disdainful approach. It really was predicated on really more ignorance. I know when I was going around and dealing with Superfund sites, talking to plant managers, I usually ask them, I said, why did you do that? You just created a huge liability for your corporation. And invariably the response was, I had no idea. They assumed if they put the hazardous material on the ground or injected into the soil, it would literally go straight to the center of the earth. They literally did not understand the movement of groundwater or that even groundwater existed. And again, it's just that blinkered approach that is really problematic, but it was predicated on ignorance. And so obviously education has to be out there. Classic design for environment, I was involved with this when it first came out. It's better understood because it has very clear objectives. You want to reduce waste, if not eliminate waste. Again, industrial ecology plays a role into this one. The other one was surprisingly easy to identify, and that is to eliminate certain compounds that persistent, bioaccumulative, toxic, carcinogenic, mutagenic, teratogenic. Those compounds need to be eliminated from both the process and certainly eliminated from the product. And as a result, you need to be thoughtful about the chemistries and the processes and eliminate non-hazardous substances, substitute non-hazardous substances for hazardous substances. For designs for sustainability, it's interesting. The pushback that I got quite a bit was, okay, Jim, what's the end game here? Are you trying to save the world or save the company? And of course, the answer is both. And it really is being a lot more thoughtful about that full system that we just described. Looking at resources, what are the implications if we continue to use petroleum as our starting material? Do we need to think about evolving to more biologicals derived origin sources? How do we extract it? How do we use it? How do we manufacture it? What chemistries to use? What processes to use? All of these things are part and parcel in terms of making that product. And the product itself has to be thoughtfully designed. So therefore, you design for systems thinking, how you integrate into quality, productivity, environment, sustainability. And you shouldn't see these things in total isolation. And I'll give you a good example. Issues around quality. If you have a good process control system that can enhance and define the quality product that comes out the other end, you've minimized the amount of waste. Because if you go, assembling all these materials from around the earth, putting them into component parts, defining, if you will, the active component of your product, and then essentially rejecting it when it comes at the tail end, the amount of waste that essentially precedes you and all of that is huge. It's gigantic. And we'll talk about that later. But nonetheless, it would be good to partner with the quality folks so they understand the implications of rejecting materials and the need to put, again, both systems, process systems, and management systems in play to enhance their quality. So in R&D, these teams that go out, they design for X, you have assembly, compliance, disassembly, environment, manufacturing, reliability, serviceability, testability. You can see that you have a relatively complex checklist, if nothing else, of all the things that have to be considered. You also want to look at the product itself. You need to survey customers and see what they need. You need to address competitive products, comply with regulations, design those products to be socially useful. And of course, surprisingly, a late entry in this whole list is make sure you protect the environment. And now, of course, the question is, how do you input sustainability into all those other issues, which of course are part and parcel of all those things. So it becomes much more of a integrated effort in terms of what you're doing with companies. The design teams themselves, usually the core team is a series of specialists, designers, engineers, packaging people. Then you have an extended team, legal, sales, are we going to be able to sell this thing? Finance, we're going to be able to pay for it. Purchasing, we're going to buy the right supplies in to make the product. And so as a result, you need to provide these groups with guidance in terms of how to design for all those other issues that I just mentioned. Now, within R&D, there are a series of different steps, usually called gates. And that is, the first in the development of the product is you have a concept, you have an idea. So you take that idea to preliminary design, gate 1. Gate 2, you're going from preliminary design to mature design. Gate 3, mature design to development. Gate 4, development to manufacture. Gate 5, of course, manufacture to sales. Now, in each of those, there can be inputs to certainly issues around sustainability, issues around industrial ecology, and of course, then the circular economy, so that they understand that they don't necessarily have to rely on extracting materials in order to get the material for manufacturing that. So it becomes very important. Now, the other thing you have to realize is that for many companies, the attrition rate, the failure rate is huge. And so therefore, if you put too much effort into this in the beginning, you've spent an awful lot of money, which is going to make some people very unhappy, and they'll be very disappointed with issues around sustainability. So you have to be able to balance that, so you need to literally input into each of those gates the right amount of information, the right amount of tests, right amount of checks to make sure that when it finally comes out to the manufacturing sales, all of those things are then incorporated. The other thing you need to think about is the product life. And that's going to be different depending on the product. Some product lives are long, some are single use, and therefore literally fleeting. And that product life does influence R&D, and it influences those gates that we just talked about. So you need to be aware of that and bring that in. The other, of course, is how do products get manufactured? Um, Product design usually falls generally into one of two categories. Either the market essentially wants it and pulls it in, or you innovate it, you create this new product that people weren't aware of and push that out. Classic example, of course, of innovation push would be things like a fax machine, an iPhone. Those are things that people didn't necessarily knock on the door and say, I want this, because they couldn't even imagine it would exist. I mean, a little device you can put in your pocket that you can use as a phone, a device to essentially, scan and surf the internet, a means by which to take pictures, a means by which to play games. I mean, all those things are in that one device. People before that was invented, would never think of it. So therefore, there can be both of those. You need to be appreciative of that and see which one you think is appropriate. The expression itself is the combined effect of all elements of the product. And of course, the idea is to make sure that people want to buy the product. Marketing comes into this. That's why they look at the color, the shape, the size. That's where Steve Gates essentially really shone. That was his big, claim to fame. That's what he did with the iPhone. He really wanted a certain feel and touch and approach. So therefore, product designer has to think about what the consumers are going to want and how that's going to influence their ability to buy that product. So solution is to create a product that it both has the appropriate appearance and the appropriate function. And it has the right attributes that essentially attracts the customers. Now, it can have attractive appearance, but it isn't functionally appropriate. They're going to drop it. The same thing's true. It may be functional, but if it's clunky looking, it looks awful, that might not necessarily be good. So therefore, you need to have an integration of those two concepts in the design. Overall, product design is not an easy task. You have to appreciate how complex that is, especially if you're trying to influence it. If you're going to go back in and try to change this, you need to understand the hurdles, and you need to be at least sympathetic to the challenges they have. And of course, stakeholders all demand something different from the product designer. And the manufacturer is concerned primarily with the cost and its ability to be sold. So therefore, the manufacturer wants an economically costed product that he then can hopefully, price at a much higher level and get a maximum profit from it. The purchaser itself, he or she looks at the price, the appearance, the prestige, and don't dismiss the prestige. That can be a big factor. It's also concerned with usability and functionality, make sure it lasts a long time, make sure it's easy to use. Not always interested in repair until the thing breaks. But it is a factor more and more that can the product be easily reassembled, disassembled, diagnosed, and serviced in a way that's not expensive. And that goes back to the issue of modules and component parts that can be used for different types of products depending on what it is. So the product designer has to incorporate all that in there. The trend, of course, is that they need to consider all the use factors as well, the third step. So sometimes people abuse their products. There can be faulty products, there can be errors in the design, and there are ways in which people wish they could use the products but can't because of the way it was designed. So in many cases, as I said, the level of attrition is huge. Products will fail even if they go into the marketplace because customers won't pick it up. But you also have to understand that products become obsolete. There is a natural life cycle to a product, different from what we think about a life cycle, but it's literally the launch of the product to its plateau of consumption, and then a decline when a new product takes over. As an example, LCA can drive innovation in business-to-business sectors. Millipore launched a purification recycling device. And what they found, of course, is the recycling scenario was actually somewhat higher carbon footprint. So they needed to be much more thoughtful in terms of what they were doing with the product and what they were doing with their recovery. And so Joanna Jobin came back and said, look, we understand this is just one initiative along our sustainability journey, and we need to collaborate with the customers to make sure we can reduce those life cycle environmental impacts. Lighting, Rudd Lighting came up, and they were looking primarily at upstream uses. And so they've had a screening level LCA driven by customer demands and marketing requirements to back up their green claims. and the job was to produce products that were both economical and sustainable. So with that, just a reference to the fact that LCAs can also be brought into the mix in terms of the product evaluation. The question now is, what's the future? Quality assurance is no longer a differentiator. Having a high quality product, doesn't necessarily create a difference for you in the marketplace. That's something that's seen as just a rock bottom demand, a need, a must have. Same thing is true with environmental life cycles. It becomes a de facto standard, not always just regulated, but companies more and more recognize they need to think about everything from extraction to end of life. And so therefore, the acceptance of an industrial ecology life cycle approach is just much more readily available. And designers have to consider these different components in a way that's very innovative. We may see those as obvious, but and a lot of people look back in time and go, why did we ever design them unsustainably? They can be very, very effective both in the marketplace, the bottom line for the organization, and they can be very substantial. So this again becomes very key and critical to what we're trying to do. So with that, question comes as to what are the right tools to use, and it does create a certain number of points of confusion. It's unclear how existing approaches are complementary or distinct. How does the company assess its current products? How would designers create more sustainable products? And what criteria to use? And so therefore, you need to be very thoughtful about how you address all of those questions, because they'll come to you from the product designer. So they have to understand there's interconnections between assessment strategies, principles, actions, and tools. And so therefore, in the past, they have suggested a roadmap for different product designers so they understand what's out there. My own example, obviously, I created a software package called Flask. It was fast life cycle assessment for synthetic chemistry. It gave them literally a single number to compare their different synthetic options for a given route in a way that was beneficial. Heretofore, it was a whole jumble of issues, and I needed to be able to bring that down and simplify that. And that's essentially what that roadmap did. Now, I was fortunate that the results of that life cycle assessment was essentially correlated very well with the ultimate cost of that particular synthetic route. So therefore, it was well adopted in that regard. So overall, what you want to do is make sure you integrate sustainability in the product design. You want to look at defining the outcomes and successes. You want to look at the core strategies you're going to use. You need to think about customer input, marketing requirements, the functional requirements in that. Environmental, human rights issues are out there. You have to be able to ensure your supply chain does not violate human rights issues. And you need to make sure that you factor into this at the right point in time when you go from feasibility to preliminary design to functional specs to, again, a given business plan. And so with that, come to the conclusion on this one. I know it's an awful lot to handle in one session, but hopefully we'll be able to discuss this in class. Take care. Talk to you later. Bye now.